Alright, lesson 4-2, Polygons and Congruence. Hopefully by the end of this you can say I know the definition of a polygon, I know the definition of congruence, and I know the corollary to the definition of congruent triangles. These three things are going to become important, so again, make sure that you're taking notes on all of them. This is kind of going to be a starter lesson for then what we're going to then be covering on later into the chapter. So to start off with, just a couple definitions that I want you to write down. A polygon is a connected set of at least 3 line segments in the same plane such that each segment intersects exactly 2 others, one at each endpoint. So that's the formal definition of a polygon. So again, just think about it as, if you think back to before, where we basically said it's a bounded shape, basically meaning that it's connected. The entire thing is connected. There's not a space open of at least, it has to be at least 3 line segments. So obviously if it's only 2, well then that doesn't actually finish a complete connected set. It has to be in the same plane so that then it's, again, flat, 2 dimensions, such that each segment intersects exactly 2 others. So each side is going to basically connect. So if you think about a, we'll go through some other shapes here in a little bit, but you think of a square. So if I basically think about the entire screen here as a square, that the top part of the screen basically is my line segment, and it's going to intersect exactly 2 others. So basically meaning the left side of the screen and the right side of the screen, at one at each endpoint. So our corners pretty much of our screen here. Okay. So write that down. If you need to pause it, do so. We're going to move on. Line segments are the sides of the polygon, and their endpoints are its vertices. Now this is stuff that we've covered before, so if we think about this shape here, the line segments we would classify as the sides, and the points here, a single point is called a vertex, multiple points are called vertices. If we're going to name polygons, obviously there are special names for more common polygons that we use, but if it's just in general, if n, basically meaning is a number of the sides of the polygon, the name of the polygon is an n-gon. So this is typically what we use when we start getting higher up into the more complicated type shapes. Like if you look down here, here's a 14-gon. So if the number of sides, obviously there's going to be 14 of them in this shape. So if 14 is the number of sides of the polygon, then the name of the polygon is a 14-gon. We can specifically say, so if 3 is the number of sides in a polygon, the name of the polygon is a 3-gon, which we more specifically call a triangle. But any generalization, again, I will probably ask you later on to be more specific with your actual naming of polygons, as we've covered before. When dealing with shapes, we want to talk about congruency, because this is what basically chapter 4 is going to get into a lot of. And if something is congruent, it basically means it's the same size and the same shape. It's exactly the same. It could be turned, but basically it's that same exact shape and size. Nothing about those two things has changed at all. And finally, for our learning targets, is if we have 2 triangles that we say are congruent, so it's if 2 triangles are congruent, then there is a correspondence between their vertices, the endpoints, such that all of their corresponding sides and angles are equal. So meaning that if we say that 2 triangles are congruent, then we know that they have corresponding sides and angles. Now, if we take a look at these 2 triangles, I know you can, or it's kind of getting cut off at the bottom here, but if I take a look at what is DE and AB, there's 2 lines going through the sides here, and there's 2 lines going through here as well. We're basically saying that these 2 sides are exactly the same. If I say AC, which is my hypotenuse here, and DF, which is my hypotenuse where my mouse is moving, those both have 3 lines there, which they are equal to each other. Angle A, as you can see, has 3 angle lines through it. Angle D also does as well. So there's a correspondence between the angles as well. All of them are equal. All of them are equal here. And we're going to be exploring different types of proofs and different types of properties and theorems that are corresponding with triangles and how to prove that they are congruent. Now, this if and only if, before I move on, again, realize that if there is a correspondence between their vertices such that all of their corresponding sides and angles are equal, then I know that the two triangles are congruent. That's going to be pretty much the majority of what the chapter is going to be about, is proving that these sides and angles are all equal. Therefore, I can conclude that the two triangles are congruent. And we'll talk about more of this as we go along. But make sure that you get this down in your definition or in your notes. Last piece here, again, would be to write down basically convex polygons. So a polygon is convex, basically meaning that if I pick any points at all along this, inside this shape and the interior of the shapes, that means that, and I connect the points with a line, that entire line is going to be contained within that shape here. That's the formal definition of convex. Again, if I could slide all the way A up into this corner and I put B in any other corner, as long as that shape is convex, we will basically always have AB inside of our bounded polygon here. Now a concave, the opposite of that, is a polygon that's not convex, as we call concave, which basically meaning, if we think about it, so if it's not convex, that means that there is a place in which I could draw 2 points and the line segment AB would go outside of the polygon. Now obviously if I drew it right here where my mouse is moving, it would still stay on the inside. But if I put my point of A way up in this corner here, and I put my point A or B in this corner here, and I drew a line through it, obviously, as you can tell, it would exit the polygon and then re-enter. And so that would be considered concave. Now these two things are going to become important when we get to the actual homework next class period. So please write all these notes down for me, and I will check them the next class period, so that then during class we can be able to work on our homework. So thank you for listening, and we will see you later.